Yeah, I'm ready whenever you are.
Okay, welcome everybody. Just a short introduction here, just to explain who's around. So this is part of a master's level course that I'm teaching, cloud architecture, and what we do in this course is try to get in speakers from industry who tell us something about, well, in this case, the cloud that is relevant to the course. But I've also invited a number of other researchers, and a couple of people from industry here. And this is, again, something that will hopefully be interesting to all of us. So you've seen already in the title, the key point is around the cloud. It's about DevOps, containers, a couple of those topics that are pretty hot at the moment in the community. And that will hopefully give us a better understanding of how those various technologies fit together and how they will shape the future. So our guest today is William Henry. William is actually one of the graduates here from the School of Computing quite a long time ago. I've even spent 15 years in DCU, but William left us before that. And he has quite an interesting career, now ending up in the US working for RedHat for the last, I think, 8 years. And a senior consulting engineer, and then again very deep in the technology and on the DevOps and container technology strategy in RedHat. Okay, I'll hand you over to William, or maybe just one more comment. We've planned it as a kind of two-stage evening, so there will be a classical presentation. We have a short break later on, and then we're going to go on to something a little bit more hands-on to show you about container technology and how it actually works. So that's the plan, and
that's great.
Go to William.
Thank you very much. Thank you. Before I forget, I see someone up there with a DCU shirt. Is the shop still open this late if I wanted to get one of those? Because the one I have is really old, and I need a new one. The one I had was one of those stitched ones, you know. It was no, it was DCU, but it was a stitched pattern. Anyway. Yes, as Klaus said, I graduated here in, well, I'll just put up, I have a few slides. Sligo, I know, don't take that hard and don't give me a hard time, but I grew up in the Wild West of Sligo and attended DCU from 86 to 90 when it was NIHE. I was, the 1990 was the first year that people got bachelor's degrees that had Dublin City University on it. Before 90, it was all NIHE degrees. I then worked. I also during that time I did a J1 visa to the United States in 1988. Worked for the IRS on a subcontract to the IRS, doing mainframe stuff, and then when I came back, that set me up nicely to get an intra placement at IBM for the 6 months of intra, which was really great experience, and was all set to join IBM in graduation in 90, but they had a freeze there. I wonder had that anything to do with our friend. Anyway, I ended up working for a small startup called Third Wave Limited and did 2 years in England doing consulting in London. And then came back, I got sick and tired with that and came back and did 2 years of a master's by research here at DCU and was one of the people who helped the DCU bar break all Guinness records at the time. They had, it was actually the biggest distributor of Guinness was in DCU bar at one point. Did you know that? That was during my tenure. I did my best. Anyway, in 94, I was about to transfer into the PhD program, but I got the green card. And so it was like PhD, green card. I decided I will take the master's and head off and move to Colorado where I worked for MCI Telecommunications. I got into the telecommunications business and learned all about scale and fault tolerance and 9X and all that sort of stuff. Also, because my master's had a lot of object-oriented work in it, I ended up doing some OO work just when Corba was coming online. got involved with Corba and Orbix, and ended up working for, I started a new company with a few other guys, and we got bought out by Iona. And I told them, whatever you do, don't tell them that I'm Irish, or they'll just say, I'll give him a t-shirt and a six-pack and he'll be fine. So I did manage to get some money out of that acquisition, and stay there until 2008, and got a call from RedHat and asked me to come over to the CTO office there as a distinguished engineer. They call it senior consulting engineer. And I've been working on emerging technologies there, so I did a lot of cool new stuff and continue to do cool new stuff around cloud technology, and recently around containers and Docker and Kubernetes and Mesos and stuff like that. And that's what we'll talk a little bit about tonight. Everybody okay so far? Right? Because these things are now, as cloud has become, has exploded, but also not just public clouds, like the Google Cloud Engine and Amazon, but also the people deciding they're having their own private clouds. There's a lot of new design patterns and architectures coming out of that, including a revolution around containers, and we'll talk about Linux containers in a little while and how they fit into all of that. And this talk really, well, let's first of all mention this. So what we're also seeing now, and you're probably seeing it here too, is just the whole digital disruption. So before, you had massive companies doing IT, and then you had all the cool startup stuff, and now what we're seeing, startup tech stuff, and now what we're seeing is a lot of startup companies that are using high tech, but to gain a competitive advantage and just enter a market and take it over. So these are companies here, like Uber is the largest taxi company in the world. It doesn't own any cars, right? Facebook is the largest content manager or owner in the world, and it doesn't own any content, right? It doesn't produce any content. Alibaba and Amazon are biggest retailers in the world, and they don't have any retail stores. Airbnb, biggest reservation system in the world, it doesn't own any hotels, right? So huge disruption of people who recognize a market and are making use of IT to fundamentally change how that market is working and threaten those markets, right? So everybody, even banks today, are worried, is someone going to enter their market and become the next big bank? I'm sure some of the banks are concerned about things like Apple Pay and those, right? So you're going to have people who never existed enter a market and dominate it. So we're changing from the old IT world of the sort of systems of record to this idea of systems of engagement, right? So the mobile devices, tablets, and phones obviously are just driving so much of people's expectations through the roof. So for example, oh, well, one more slide. What this sort of discussion tonight is about, how we've kind of hit this sort of perfect inflection point of where, I mean, you know, there's always these inflection points, but right now, for me, when I look at it, I see just an explosion of ideas. Like when I go to bed on a Friday night and I think, okay, I have everything sorted out, I know what all the cool projects are, I know where all the cool tech is in my head, and then you come into work on Monday morning and someone says, have you seen this new thing out on GitHub? You know, and everyone's downloaded, and suddenly it's the greatest big thing since sliced bread, and you're like, can someone just take GitHub down for about a month so we can all just catch up and breathe, right? Because it's just, the innovation has happened so fast, and it's because of things like open source, first of all, you know, GitHub and other repositories, Apache and stuff up there, just where people are sharing ideas, communities are forming, and a huge amount of technology is coming out of it. Mobility is driving it. Then there's cloud. Cloud is allowing people to turn around and not have to spend a lot of money to just bring up some resources somewhere. They don't have to go out and buy any hardware or you know, servers or any virtualization environment. They just go out to Google Cloud Engine or go to Amazon, spin up a few instances, and instantly they can start developing, doing some testing of their applications, and then have full production environments up there with no capital outlay whatsoever. DevOps is, as we'll talk about, is really driving then the automation as more and more of these technologies have APIs that are consumable, whether it's REST or web services or what have you. Now people are beginning to think, well, you know, my development process doesn't have to have all this manual intervention anymore. I can suddenly automate so much of what I do, particularly now that I don't own any assets either. They're all up in the cloud. So we're also seeing DevOps drive this. And the revolution around containers, as we'll see, has allowed for much more density, lowering costs more, but also fits into the DevOps model because literally the work that I'm doing on my laptop is the same environment now, or can be the very same environment for my application as it's going to run in production somewhere, right? So that's what we're going to talk about tonight. So when I turn around and book a flight for Ireland, I get on my Delta application on my phone, and I book the application. The reservation system on the back end is open source, right? Same thing with my hotel reservation when I do that. When I look up when I use Waze application for my GPS to get to the airport, make sure that there's no traffic or watch out for police. I don't know if you've used Waze over here. It's an application that'll tell you if there's other people in the Waze community report on road conditions. So not only is it a navigation, but it tells you, oh, watch out, there's a policeman up ahead on the right, or there's an accident up ahead, and it'll actually steer you off the road if it's quicker. So it's much more dynamic and interactive. That's open source. When I get to the airport, all of the timetable systems are all backed with open source. When I get to on the plane, those little TVs, often if some of you have seen them, will pop up with the little Linux penguin there. They're open source, based on open source technology. When I get over to Ireland here, I can use SIP technology on my phone to call home. I can check my bank records and my retirement plans, all with the banks that are all running Linux on open source. There's just so much open source. So when you get this nice proprietary Apple platform, or you're on your Android, just know that for the most part, on the back end of all this, it's driven more than ever before. All of these back end applications are driven by open source. So how do you manage all this, right? There's hundreds of thousands of projects. And I says, when you go to GitHub, there's new projects happening every day, even within the community. So if you're up on OpenStack or you're in the Kubernetes environment, you'll just start to see all these new forks that get merged back in as more contributions happen. So you end up with hundreds of thousands of projects, whether it's on the big data side, projects like Hadoop or Spark. Is Spark open source? I can't remember. I think it is, yeah. And then you have Apache stuff for middleware like Kafka and Cupid and all the Fuse technologies. ManageIQ, which helps you basically navigate, do some sort of smart resourcing around where you're going to place your cloud resources, whether you're going to use Rev or VMware or some public cloud. You can use ManageIQ for that. OpenStack is an entire essentially cloud infrastructure developed by the open source community. So huge amount of explosion of ideas. It's very hard to manage them all. And just to tell you how this is the only time you'll ever see the RedHat stuff up here. It's just how our model works at RedHat. We're like the first open source company that's going to hit 2 billion. We just hit 2 billion, I think, right? 2 billion, that was announced. We hit the 2 billion mark. So we do free software, and we do 2 billion a year in free software now. So you have hundreds of thousands of projects that are all their own little communities, and then they feed into these larger communities. So say Fedora turns around and goes out and gets GNOME, it gets GIMP, and other projects from this big pool and says, okay, this is what's going to make up Fedora, or let's say, where's the other one? I don't see OpenStack there, but RDO, yeah. So RDO gathers up OpenStack plus some other projects and bundles it into an OpenStack offering called RDO. And these are all the upstream free projects. And then what Red Hat does is, at a different sort of cadence, these might be 6 months for Fedora. Every 6 months, a new version of Fedora will come out. But then Red Hat will turn around every 18 months or whatever and say, here's a hardened version of this. It's got full support. It's got, this is the certificates in terms of making sure you're getting the right version and all that. So we essentially, we do a lot more than support, but it's indemnification and all that good stuff. But we manage to monetize this through this sort of process, right? And every Fortune 500 company, whether it's finance, government, or healthcare, telecommunications, but also governments around the world, all use Red Hat technology. Okay, so quick switch now over to down in the weeds stuff. How many people have played with Docker here? So we have a few people who are playing with Docker. Okay, so we're going to actually play with Docker later, and you can leave here tonight knowing how to do some Docker stuff, and you'll be very pleased with yourself. But like a lot of technologies, you know, you get the whole Hello World demo up and going, right? Well, in the same way with Docker, the whole container world, you think of yourself, you're in your office, and you go, okay, I need to, Docker is this cool thing, everybody's talking about it. You install the Docker RPMs or whatever on your Linux box, and you do a Docker run Apache server, and up comes an Apache server on your box, and you're thinking, this is fantastic. It's like we just won the Rugby World Cup, you know. So then you think, well, it's been so successful. This has been so great. Let's just containerize our entire data center. Okay, so we're just going to put Docker and all these cool containers everywhere. But you're trying to figure out, well, there's a lot more steps, as we'll see, to doing that. And so tonight we're also going to spend a little bit of time figuring out how Docker works. Those slides were slightly out of order, but that's okay. One of the other big problems that we have within the IT environments today is this friction between the development side of the house and the operation side. So this is where DevOps comes in. How many people have heard of DevOps? We have some hands, right? So DevOps is very much a cultural thing. I think I have a slide on that here. But it's also about tools, as we'll see in a moment. But why do we even have it? Well, traditional lifecycle methodologies like waterfall and all that good stuff, if you're as old as me and you were doing at MCI, for example, back in, say, 1995, on December 17th, there would be a deadline to put something into production, right? And so everybody's been working on things for months, and now the big date is to put something into production. And it was like this for a long, long time, not just then. But everyone's up that night because whether there was database passwords or configuration files or something was missing, and you try to cram it all in, and then maybe 3 in the morning after lots of fighting and people getting upset with each other and people never speak to each other again. The system was in, but everybody was wounded and egos were burnt out, and there was also a huge amount of what they call technical debt built up around getting that in, because a lot of stuff was done to get it in, and people say they wrote it down, but now we need to turn around and backtrack and try to get that fixed. And it's been like that. It has been like that for a while. It's still, a lot of organizations work like that today. So what has happened is, as we've evolved, we have operations on this side are essentially trying to keep the lights on. Maybe 80% of their budget is just, let's get the same apps running continuously, that's fine. But remember that whole explosion of ideas that we were talking about earlier, and the fact that the Ubers and the Airbnbs and all these folks are thriving, right? Well, if you're a traditional business, you've got lines of business trying to keep up with that, right? They're trying to figure out, how am I going to keep up when someone's about to threaten my market, right, with some cool new thing. They're going to do things differently. And here am I waiting on these guys to just get me a VM, right, a virtual machine so I can work on it or something. So these guys often end up turning around and doing what we call a shadow IT. So they'll fund, the developer will say, look, I can get this application up and running, no problem. Just give me, I'll use my credit card and I'll go out to Amazon and I'll bring up some instances on AWS, on EC2, and I'll get some storage and I'll build my app and it'll be on MongoDB and I'll use Ruby and all this good stuff. And the lines of business are, this is great. Suddenly they're seeing turnaround. But then all that debt there, has to, someone says, wait a minute, that's a successful app. How much are we doing on it? Oh, we're doing $5 million a year on this line of business. But these guys aren't even managing it. And we don't even know what we're doing and how are we going to update it. And the developer who was doing the MongoDB stuff has left to some startup down the street and we don't know how to keep it. So what you have to try to do is find a way of bringing these two groups together. And DevOps is about not just about tools for continuous integration and continuous deployment. We'll talk about that in a little while. But it's also about this whole cultural thing of changing the way business and operations are working. You're trying to turn around to the business people and say, okay, lads, let's talk more to the operations folks. Tell them what you're trying to achieve. And operations guys, you have to be in line with these guys, providing the right type of assets for them to use. And trying to automate the tool so the developer is not hitting walls when trying to get into production. So the whole idea around this, I think it was in 2009, at some conference somewhere, Netflix described how they were doing, allegedly, I'm going to say allegedly because I've heard this second or fourth or fifth hand, but they said something about how they were doing 9 deployments a day, right? And someone tried to correct them allegedly and say, oh, you mean 9 deployments a year? What do you mean by 9 deployments? He says, no, a day. We do 9 deployments a day of Netflix. And that was in 2009, right? So you could be on Netflix watching a movie and underneath the covers, the VM that you're running, you could be switched to a new version of the technology and you're still watching your movie. I mean, it was just, today, Google and Amazon, Google, remember, has one large, huge repository of their code, and they do, I think it's 9 point something deployments a second of Google, right? So that's when someone does it. Yes, I know, it's ridiculous, right? I mean, it's mind-blowing stuff, but it's because they've essentially automated the entire workflow process to get to where they are, right? So the idea, though, is you can't really change that overnight. You tend to have to spend some time picking some cherry projects and deciding, okay, this new project we're going to do in a DevOpsy way and try to automate it as much as possible. And then if we learn some cool stuff about our organization and how we work together as a team, then maybe we'll pick another project and then maybe we'll do something with one of our legacy projects to automate that as well. So even RedHat right now is, we have some of our newer stuff is on a very automated scale where we can do multiple deployments a day if we wanted. Is that true? Yeah, it probably is, but some of our old stuff like Red Hat Enterprise Linux, it's not like we can deploy that in an automated fashion at this sort of speed, right? Because there's a lot of packaging and everything we need to do. So what is the development, the desired sort of CI/CD process would be, I would go out to GitHub or wherever my repository, I'd make a clone of the repo. I might write some stuff on my laptop. I would do, I would test it a little bit on my laptop maybe. Then I would do a git commit to my own repo, and I might do a pull request then on the community repo or the project repo. And as soon as it hits, as soon as I do that pull request or that push or whatever, it kicks into a fully automated process. It turns around to build things, it turns around and runs the tests on it. If the tests are successful, everywhere along the way, if things are successful, it moves on to the next step. And deploy here could be deploying into the next environment, which could be quality quality assurance, or it could be quality engineering or some sort of smoke testing environment. And then if it passed that, it could go straight into production. And that's what's happened at the likes of Netflix today, and Netflix and LinkedIn. LinkedIn have 2 scheduled deployments a day, but they can do a deployment whenever they want, apparently. And most organizations are trying to get this where instead of the normal life cycle, because think of it, nowadays you're moving and working on so much stuff. If you had a December 17th release date, and you called me up and said, hey, William, you know, that code that you wrote, I'd be like, what? That was back in like March. What are you talking, you know, or whatever, June. What do you mean that you forget, right? Now you can instantly see whether your code's going to make it in or not, right? And so perhaps here, after it goes through most of the tests, someone turns around and says, how does this, you know, it gets notified and told, William has actually committed some code, has passed the tests, and they can look at the code and see what you've changed and go, yep, LGTM looks good to me, and they press a button and then it goes on to the next step delivered. We'll see why this is important, or why containers are important in this in a little while, because that really makes this streamlined. Because if you can imagine, if you're doing development here on your laptop on OS 10 or something, and then you're going to be deploying into enterprise Linux, a lot of things could change between here and there. But if you're doing it containerized, we'll see that makes a lot more automation possible. And of course, this continuous integration and continuous deployment in DevOps has to happen not just on your laptop or whatever, but it has to progress through these environments. So you have this, on the top here, this sort of event chain, if you like, of different events happen and trigger other events in different environments. And then you have repositories of images and code and metadata down here that happen. But even in that world of the pipeline, most of the tools there are all open source as well. Whether it's things like Jenkins or OpenShift or Ansible or Jira. So many of the tools that people use in CI/CD today are also open source technologies. Puppet as well, even the Feed Henry stuff from all the mobile, we're open sourcing that. That's the Irish company, the mobile company that RedHat just bought last year. Was it last year? So we'll open source that. That's one thing about RedHat, is the biggest arguments in RedHat is how fast we can open source stuff. So people will buy a company with proprietary software, and people will be fighting over how come it's not open sourced already. It's like, gosh, we only bought them yesterday. We have legal issues and stuff like that about getting it out there. So, but everything we do is open source upstream in the community. So now, with what I'm saying is that with the containerized world, what we're seeing is we're able to increase business agility, accelerate developer productivity, and scale to a public cloud faster if we want to, using containers. Okay, so now I'm going to a little bit down in the weeds. What are Linux containers? Anybody, any Linux geeks here on this? Okay, besides Dave, who's yeah. Okay, so Linux containers are a technology that allows you to provide isolation of a process and its namespace on a machine. Okay, so it basically allows the process to be kind of locked inside of itself, right? And it provides it certain resources. So it can turn around and say, look, you're only allowed to use this much of the CPU, or you're only allowed to use this much memory. So there's technology in Linux called C groups that allow you to do that. This, by the way, is not new technology. It's been around for a long time, but it's just become really cool and fashionable right now. And there's a reason for why that's happened. But basically, you can turn around and say to this process, hey, you're kind of like a virtual machine, a lightweight virtual machine. But you're not. There's no hypervisor or anything like that. It's just the kernel is going to isolate you, give you a certain amount of resources and a namespace, so that you can't break out of there and you're running in isolation. So the idea, what's happened now, we've been using containers ourselves at Red Hat for quite a while, including in the OpenShift technology that's up online, our public platform as a service. But what happened last year early last year in 2014 was a company called Docker out of California that were also in the platform as a service business realized that they were down the list of platform as a service people. And so they were thinking, well, what are we going to do about our business? And then they said, well, this technology that we have and how we do containers, Linux containers, it might actually be worth something. And it turns out it is. So they open sourced Docker. People jumped on, including Red Hat, very quickly and says, this is great, we'll jump in. And I'm going to talk a little bit about what that is. So Docker builds on Linux containers, and it adds an API which makes it consumable. So now you, as the average developer, doesn't have to worry about things like C groups and namespaces and all that. I just want my application up and running, right? It provides also a image format and a layered image format that is very, very powerful. So what I can do, I'll go into that in a moment. So the idea here is, on the host, the only thing for containers to run that is really required on the host is the kernel, because the kernel itself supports containers. It knows about C groups and namespaces and all that cool stuff. What Docker provides is an API to be able to talk to that in a way that you don't have to worry about all that complexity. But then your container, it uses the underlying kernel, and then inside of it, it contains only the libraries and application code binaries that it needs, nothing else, right? So it's not like, when I install my Fedora on my laptop, I get all sorts of stuff there. And if I install the GCC compiler and the Java, it's all there on my machine. Within a container, I can get a very base image of Fedora, which not much in it, and then turn around and say, okay, for my application, I need Java, so I'll install Java. And I also need, let's say Mongo. Well, no, let's just say all I need is Java for this. So I install Java inside my container. It brings in whatever Java libraries I need. I write my Java code, and I put that in there, and now it can sit here. And you can imagine I can now have a lot of density on this. I don't have a full distribution of Linux for every one of these things I need. I only have the application libraries and binaries that I require. Okay, so some of the most advanced infrastructures in the world are running on containers. So Google, I've heard, deploys, I heard this just yesterday, like 10 billion containers a week or something ridiculous. That's how many containers it deploys. Everything at Google, from the search engine to Gmail, is packaged and run in a Linux container, right? OpenShift, when we started with OpenShift, we were just messing around with containers at the time, and one of my colleagues, a guy called Jan, it was his credit card that was being used at Amazon EC2 to pay for the infrastructure for OpenShift Online, right? So the idea was we were going to try to attract developers to this platform, and so they could come in and do a la carte. Oh, I want to create a new app. I want to go and I need MongoDB and I need Java, right? And it would turn around and build you a little container for your application and a nice little Git repository, and you could clone that onto your laptop. And whenever you did a push on your laptop, it pushed the code up and built it up in OpenShift, and it was live. It's really cool stuff. You can download it or play with it later. But so we did that, and then Jan says, hey, we're spending a lot of money on Amazon EC2, so the big thing we were trying to do is that density I was talking about. How many containers can we move on to a single Amazon M1 large or whatever it was that we're trying to do? And we discovered that a lot of new guys to OpenShift, they were only, playing with it, so they'd bring up their app and, oh, look, and let me change my HTML, and, oh, look, there's the change, isn't that great, right? So you get a lot of those, you can fit a lot of those on the machines, right? So, but then someone like Dave turns around and builds this really cool app, and someone mentions it on CNN or something like that, and suddenly his app is really popular, and we need to turn around and take it off the machine that's been shared with a lot of people and move his containers over to another machine that has less resource use, so that his thing is going to run much better. So containers provide some really good benefits, including portability, deploying much faster. I mean, seriously, you can do a git push and it's live on OpenShift immediately. Now, that's not really how organizations, big corporations work. But for a developer, it's really cool. You can see your changes in the cloud running immediately. Much more greater deployment flexibility. I could turn around and move because of this standard image format that Docker came up with that is now being used by the Open Container Consortium. What is it? The OCI, Open Container Initiative. They have an image format that is now standardized. So now I could turn around and deploy my Docker container in GCE or on Linux on my laptop or on Linux in my office or out on Amazon EC2, right? I can do that there. And of course, faster provisioning. We'll see that in a moment. Let's talk about that actually. Soon. This slide first. As I say, I could do this on a physical device. I can run it inside a virtual machine. I can run it in a private cloud. Private cloud is a cloud. It's where people are saying, oh yeah, that public cloud like Amazon is great or GCE is great, but I don't want any of my stuff running out there in the public. I want it running on premises here, but I like the cloud idea. Can you give me a cloud? So things like OpenStack is a cloud implementation. It's basically where people says, I want what Amazon has, but I want it running in our corporation here. So the OpenStack initiative started, and they're providing you this way of starting virtual machines and all that cool stuff in a cloud-like way on premises, right? But it looks kind of like Amazon EC2. So the idea then is I could have a private cloud and I could have a public cloud. Or you could turn around and be doing all your development up in the public cloud and then decide I want to deploy on private because I'm just using the public cloud for my developers so that they have infinite resources that they can use, but then I will deploy them on my private cloud later. So a lot of flexibility. The velocity and density. If you had a new app, 10 years ago and you weren't using any virtualization or anything like that, what you would do is you would go out and you'd buy some physical hardware. You might buy two, one for test and one for production. And then it would take you about 27 hours to deploy, right? To get it up and running, get all the stuff installed that need to be on it, all the packages, all that good stuff. When you turned around and did it on a virtual machine, you got it down to about 12 minutes. You could spin up a virtual machine. But now with containers, most containers actually I could start in about 2 seconds. 2 seconds, and we'll show that tonight. But let's say 10 seconds if you're doing it in the public cloud or something like that. And the other thing too is density. So a customer of ours who had a single app on a large machine was able to turn around and get, because he needed to scale, when they moved to virtualization, he got an order of magnitude scalability by just moving to virtualization. And then when they moved to containers, he got an extra order of magnitude. So you can get a lot of density by moving to containers as well. Okay, from the DevOps perspective, what does that mean? Let's see what it looks like. So now I have the operations guy, right, is able to turn around and say, look, all I need is a common platform here, right? All I need is a host machine with the Linux kernel on it, essentially, right? And what I will do is I'll produce a few base images like a Red Hat Enterprise Linux instance or a CentOS base image instance, or I might turn around and do a Red Hat Enterprise Linux with JBoss inside of it already installed, and I give that to my developer. Now the developer goes, great, now I have this red box here, this image, if you like, and I can turn around and I know that These guys gave it to me. So if I just put my jar files or whatever inside of that, and I then create a new image based on that base image. So I've put their image, we'll go over it in a moment, put my code inside. If I give that back to the operator, they're not going to complain. They're going to be fine about it. In fact, I don't even have to give it back to them, because then I'll have that DevOps automated process that turns around and builds the image and just moves it through the right repositories or promotes it inside a repository with different tags and things like that. Everybody following me so far? Yeah, we're good? Okay, good. So from a DevOps process now, I've managed to come up with something that allows my developer to just inject their code, if you like, into, and then it's portable anywhere. It can move in between all these environments. I can turn around, automate it completely in terms of the build process and tests, and just deploy it straight into production. So if that's the case, what about the base machine, the base host? So this is where I think some of the worries that people have around, there'll be like two camps now. I have to be careful what I say here, because in one case, you have this huge big initiative called OpenStack that says, here, we need to build what Amazon and Google and those guys are doing to do this managing of virtualized machines in a cloud way for what do we call infrastructure as a service, right? And that is really cool. But now you have this container thing coming along, and the container world is essentially saying, I really don't need an awful lot. I just want to run a bare metal with a very, very, very small Linux kernel underneath that supports containers. Maybe I'll throw in some SE Linux and some Docker to manage the container sort of stuff for me, and I can get huge densities. Why do I even need a virtual machine anymore? Now, a lot of people are running containers on virtual machines, no doubt about it. But you're also going to start seeing a shift now where people are saying, well, what gain do I get there? I'll still use virtualization because I still have a lot of applications that I virtualize in VMs that are still very useful. But I might turn around and just, if I'm doing containers around my applications, I'll just turn around and buy a big honking machine with a Linux kernel and just have thousands of these containers running on it, all in isolation, right? So you're going to see a sort of a give and take here between the sort of OpenStack side of the house, which of course we at RedHat are very heavily invested in, and these other people are going, well, geez, I don't even need, why would I even put OpenStack or any sort of virtualization in the mix there? I'll just buy a big machine and use containers. So if you did that, you would need a very stripped down kernel, right? So what happens something like Fedora or something like Red Hat Enterprise Linux? Well, we have a project called projectatomic.io. If you go out there, you'll see that what it is it's essentially, it's atomic. I describe it in two ways. One is it's atomic in the sense that it's really small. All it has is these things here, C groups, namespaces, which are all part of the kernel anyway, drivers, SE Linux for security. Sorry, SE Linux is, it provides better isolation around processes and makes sure that certain processes don't behave badly and break out of themselves, right? So SE Linux and Docker as the way to talk to containers, get them up and running, and make sure they stay running. If that's all I need, then I can provide. So Atomic is essentially that. It's like, how small can we distribute the operating system? Because everything the apps need are going to come in the containers. So that's what Project Atomic is. Okay, so now this is a section now and a little bit more deeper on Docker, because we're kind of talking about Linux containers and what they do, and we're talking a little bit about Docker and the advantages of containers and all that good stuff. So a few concepts you need to understand about a Docker are, first of all, two terms. One is image and one is container, right? The image is the just like in a VM image or even an operating system image, when you get an ISO or whatever, it's the image. It's the actual something that you can pass around and say, here, install this, right? A running image is a container. That's when you get the image and it's up and running. In this diagram here, these three layers would represent the image that I got, right? And if I started and ran them as a container, the uppermost layer of my running container is read-write. Everything else is immutable. I cannot touch these layers here. Now, the layers part are important because it helps you to essentially certify and understand assign where things are from. Because in this container world, you can imagine, with DevOps, there could be billions of these images floating around. And how do you turn around and go as a bank or a government and say, oh yeah, run that, run that, run that? I mean, you don't know what you're running. What this provides you with, every single one of these layers has their own UID. A unique number that you could turn around then, and if it's signed by RedHat, it'll say, this is a RedHat certified image layer. If it's a JBoss EAP thing coming from RedHat, it'll have its, so you could turn around and go, each layer, yeah, that's good. So before you actually run it, you can turn around and see if it's certified. You can even, there are going to be tools coming up soon that allow you to introspect and make sure that there's no spoofing going on, that what's inside a container is exactly what was supposed to be inside it, right? So anyway, now I download this particular container and I can turn around and inject, as we'll see later, using it, I'll tell you about that later, inject into it my code. And then suddenly, so my jar file or war file or whatever goes in there on top, and that becomes my new image. Once I save it, it becomes a new image. And then I can say, here's my Minecraft jar file or whatever, right? And I'll actually do that in a little while here. So the process is we got to build. So when you build your container with Docker, you use a Docker file. And I'll show you more in a moment of those. But essentially, they say, hey, use the keyword from and say from, and you give it a base image. In this case, it's the latest Fedora image, but it could be RHEL 7 image, or it could be Ubuntu or something. So from some base image, and then you could turn around and run commands in here, like say, tell it to run install Java or install this or that. I'll show you those. So anyway, you build. And then you could turn around and you could ship it somewhere, and you need to push it there's another two concepts. So we had image and container. The other concepts are repository and registry. A repository is the images on your machine, on the node, right? So when I'm turning around and doing this and I do a build, I end up with an image on my machine, right? But that's no good to you guys. I'd need to turn around and share it with you. So I would share it to you with a registry. So I turn around, I would push it to a registry, either a public registry, like Docker has a public registry. And so you can download, that's where you would turn around and get your from Fedora latest. If you do that, it'll just pull it down from the Docker registry, the Docker hub. Or you could have a private registry. So for example, if you're Aircom or whoever, or Bank of Ireland or something like that, chances are you're not going to be letting your guys go out and pull things down from public registries. You'll be saying, look, if you're doing development in this house, you'll be using our own bank registry, or you'll be using our own government registry, unless you have a private server somewhere. But anyway, and then you'd turn around and run it. And you run it either by just saying Docker run, or you might turn around and do a pull first. So I pull it down from the registry and then run it. But once you say Docker run, if it doesn't exist, it'll try to find it on whatever registry you did, and it'll run. Okay, and you can run it on a physical machine, you can run it on a virtual machine, or you can run it in the cloud. We're going to see this in a moment. How are we doing time? We're good. So I'll try and get through the lecture parts first, and then we'll do a little bit of the hands-on stuff. But your applications are usually made up of multiple containers, right? So you'll turn around and you'll build your MongoDB image for your MongoDB stuff with the configuration it requires, but you also have your JBoss stuff in a different container. And that's great, and you can do that and bring up the two containers, and somehow they can talk to each other. And there's ways of doing that on a single machine. It becomes harder when they're on different machines. But there's also another technology out there. As soon as you get up that layer, somebody said, okay, now I've got these containers, I need something to bring my application together. And that's where a technology called Kubernetes comes in. Kubernetes is a project. Do I do that next? Yeah, I'll do that in a moment. So before I get into Kubernetes, I'll just say this. Several containers can live on a virtual or bare metal machine, so you can get lots of density. And also containers are easily controlled using the Docker tools. So you can say things to Docker like, hey, Docker images, and it'll show you all the images on your machine in the repository. You can say, hey, Docker run, or you can say Docker PS, show me all of the images that are actually running right now. So you can do all that good stuff. But as I said, if you want to get applications, if you want a deployment model for your application that's multi-container, you need something like Kubernetes. So last year we were working on the Docker stuff, and we were also trying to figure out how was that going to work with OpenShift. And we had started an internal project that I won't even bother telling you the name of because it'll only confuse you. But at the same time, Google came out with Kubernetes, and we started working with Google immediately and said, okay, this is the way we're going to assemble these container-based applications together. So what Kubernetes allows you to do, and from a Google perspective, their view of it is, hey, all these people are going to be writing cool container applications using Docker, and we want them to come to Google Cloud Engine. How do we do that in an easy way? Well, something like Kubernetes can help, right? Okay, so now you could take your Kubernetes app, you can deploy it on your laptop, or you can just say deploy it up into Google Cloud Engine. Or you could deploy it into OpenShift. So now your application, which is multi-container based with all the cool stuff in it, can go to OpenShift or Google Cloud Engine or wherever you. So how it works is Kubernetes has a JSON file that tells it things like how it's going to scale up to, like, I want 3 replicas of this. Here's the image I need for this particular Redis application. I need this much memory and this much CPU. So what happens is when Kubernetes is orchestrating your application onto a machine or multiple machines, it turns around and talks to Docker on that machine and say, hey, Docker, run this image, and here's your C groups information and all that good stuff. So Kubernetes and Docker are kind of not tightly coupled, but they're growing up together, if you like, right? But there's other container technologies out there as well, like Docker, but the Open Container Initiative. Open Container Initiative, thank you, Dave, is trying to make sure that everyone makes sense of this stuff. Okay, so then with Kubernetes, this is a GUI called Cockpit that a bunch of our guys have worked with. It started around Docker itself. So it's an open source project called Cockpit. It's on Fedora if you want. But Cockpit actually allows you to point to the JSON file here and say, hey, here's a Kubernetes file, go and deploy it. And it's showing me here that I have, once I deployed it, it shows me my usage and all that good stuff, but it tells me, here's my database container, here's my front end, which is a Redis front end, here's the IP addresses they're using, the namespace I'm using. I can then turn around and tell it to look at deeper information on that. You can't see that, I don't know why I'm showing it to you. But I can also say, hey, I need to scale this up, and actually, while it's running, tell it, the front end, I need 10 replicas now, right? Instead of 3. And I press adjust, and it'll go out there, and it'll actually spawn up more containers. And the way Kubernetes works, I'm not going to get into Kubernetes tonight, but it has some concepts called pods and services and replication controllers. But the idea is that each of these containers now, which are on different physical machines, are all part of the same namespace, they're all part of the same application, and they're all working with a database service that's down here and interacting with that, right? So that's the database backend. Okay, the last thing, so Kubernetes will do a health check, by the way. One of the things it does is, if one of these containers goes down, so if something goes down, it turns around and goes, it knows its rules that you set up. There should always be 3 running at any time. So it'll turn around and it'll bring up a new one, and then it'll switch over and make sure that one's up and going. And you can do this then for things like canary systems where you're moving from one version to another. Kubernetes also supports bringing up version 1.2, for example, which has some code changes in it, live while the other one's running, and it will allow your applications to migrate over to that one. The last thing I want to touch before we leave on the lecture side of things is the scale, because you can imagine when you get into this sort of container world, cloud world, DevOps world, you're talking about massive scale. When you talk about Google scale, that's and Amazon scale, that's quite huge. And scaling is now, it's not just a space of high performance computing or grid computing anymore. It's not all, what I would call the mammoths, the big, oil and gas industry, or national laboratories, government, military guys who are massive grids to do certain things, right? I've worked with those folks, and a lot of the lessons from that are now creeping in to this container world as well, because it turns out everybody's scaling now. It's not just the Netflixes and the Googles and the Amazons, but everybody wants to turn around and bring up a cluster of machines and run gazillions of containers on it. Some of them, we'll see, some of the use cases will surprise you. But when you're looking at it, there's 3 main use cases. There's the when you're looking at the technologies that are around us, like Kubernetes, for example, but also a technology called Mesos is another popular project out there. When you look at those, it's the scale, the large scale, the diverse workloads. So people are doing different types of workloads on them. They're not just bringing up a web app, right? And also complex resource management. So those are the needs. If you don't have, you could have all 3 of these, or you could have any one of these, and you need a little bit more than something like Kubernetes at the moment. Kubernetes is hopefully going to solve all 3 of these problems, but right now it's very much around the orchestration part and assembling the app. A technology called Mesos right now is battling these problems here. So when you talk about scale, are you talking about hundreds or thousands or tens of thousands? Some of them are, I talked to, I think it was one of the large telecommunications folks in the US, and they're saying tens of thousands. You look at Apple, when they're running their stuff, they're talking in the 140,000 nodes. No, nodes, not containers, nodes. Who else is on this? Netflix, Google. Google, what did I tell you? It was a billion containers a week or something like that, right? So you're talking big. But you need to ask, if you're working with this stuff, you need to ask, well, hold on a minute, is it 5 different clusters, or is it one big cluster with all this stuff, right? Because really, it's how big is a single cluster you need to worry about. And also the big issue is throughput. If you're just bringing up a web app like the one I just showed you, and it's going to run forever, and you needed to scale a little bit and pipe down a little bit with the replicas, but you just needed to stay up, well then, Kubernetes is going to work fine for you right now, right? But if you turn around and say, no, I'm bringing up apps that are going to be changing all the time, and there's going to be hundreds of thousands of them every few days or every day, and maybe 1 million a week, then you're talking about big throughput, and you need to start considering how you're going to do that. And then, of course, the diverse workloads. If you're just bringing up a single app, you might be able to manage that on its own. But if you want to turn around, some of the other areas you might be doing is you might have your continuous integration and continuous deployment technologies, things like Jenkins and all the workflows and the test cases and all that cool stuff up and running. You want it to stay up and running all the time. You might have data analytics with projects like Spark or Storm where you're analyzing the amount of data. Also, when you're doing that, you could be analyzing data at the weekend, or you could be analyzing data all the time. So there's Bloomberg was talking a few months ago at Mesos, and they mentioned this financial problem. They had a scandal a few years ago where there was some sort of implied, it was happening, but it was discrete kind of insider information, you know, where there was price fixing with traders going on over instant messaging technology. So now at Bloomberg, they have live data analytics and analysis for compliance across all the social media for the traders. So when I turn around and message Dave, it has to intercept that and analyze it and see if I'm trying to price fix with him and send it on in a low latency way so that Dave and I still feel like we're having a real-time conversation, right? So everything is going through that. So something like Storm does that. Batch work, you know, where you're trying to do some house cleaning and set up databases, clean up databases, analyze or move around log files. There's batch systems. Workflow dependencies, where you're trying to figure out, well, I have to do these 5 things first in order before I can run my app, and then I run my app. So you can have complex workflow stuff. So that's on the diverse workloads. And then on the other side is, when you have large scale and you have diverse workloads, you also need more complex resource management. Any of you who have done grid computing will recognize these things. And I know you guys have already heard, I think, from Klaus around things like multi-tenancy. Okay, so in OpenShift Online, right, we have all these developers coming online and they're bringing up these new apps and they're playing with them. And by the way, they're not just free stuff. We've got paid for things as well where people are paying us to keep their apps up going. Well, when I'm up there and I'm playing with my new app, I don't want to feel like, oh my gosh, it's really sluggish because somebody next to me on the same machine is misbehaving, and that's where the containers are managing things, right? So when you have multi-tenancy, you have issues around storage and memory and all that cool stuff. But also you have the idea of, if you bring up, let's say you ran an OpenStack here at DCU across the different departments and you wanted to make sure, or Mesos, let's say you were running Mesos, and you wanted to make sure that, let's say that the computer applications department were the biggest investor of this and you were running it, but you, physics lab had decided to contribute some machines and the biotechnology folks put in a couple of machines. So now you're sharing one big cluster across the university, but the computer science or the computer applications, the School of Computing has the bulk of it, and so they say, well, look, we want 60%. If we're using it, we want at least 60% of the cluster to go to us all the time. And biotechnology gets 20, and somebody else gets 10 or whatever it is. But you want to be able to do a fair share across the cluster, right? So you want to make sure, so this is also important, like DreamWorks. I work with DreamWorks a lot in California, and every production, they have one huge big cluster, but every production needs to know that this week I was told I was getting 40% of the cluster to run our render farm for our movie, and you don't want to push the date and all that sort of stuff. So every day they're checking how much percentage they're working. But you also want to allow that if the computer applications department is not running at their capacity, that everybody else can jump in and use the capacity, right? You don't want to sit in there idle. So if biotechnology have some cool thing that they want to be doing, some DNA research or whatever, let them have as much as it. But as soon as Klaus and his boys come back in and want to take over, you want to do preemption and kick people out, right? So there's all these complex resource management issues that you end up with when you get into large clusters with shared and diverse workloads, right? You might have people who say, I need a GPU, and there's only a certain number of machines at the university to have GPUs and things. Okay, so Mesos is a framework for providing, Mesos is an engine that does large-scale resource management, and it doesn't know specifically about these type of workloads, but all of these projects have frameworks that sit on top of Mesos that allow you to to do this, right? So the technologies we've talked about so far tonight are things like Docker for the containers. We've talked about Project Atomic as a platform for running containers on. We talked about Kubernetes for orchestrating applications and packaging them up. Mesos is a technology for massive scale deployment of diverse workloads on a single cluster. This is the last slide, and then you can, those who are burnt out can go, and then for the rest of you, I'll do a little demo. But do you want to containerize everything? Well, I would say yes, you do, but probably not immediately. And certainly, if you've spent several million euros on a application and move it to virtualization and to run it, on a KVM somewhere or whatever, you may not want to turn around and go, okay, now we have to migrate it over to containers, right? What you might want to do, though, is if you've got a large Oracle database running on a virtual machine, your new apps may still need to talk to it. And your new apps, you might be able to containerize and start talking to your Oracle database that's in your VM, and you can figure out how to do that. But then you might turn around and start breaking up into what they call the microservices. So we talk a lot about microservices. These containers kind of enable this concept of microservices. So then you might decide, I'm going to migrate slowly my application off of my big VM machine or my big bare metal machine and slowly containerize it service by service and then deploy those for my application. Okay, so before I how am I doing? I did okay. So any questions? First of all, as I said, I talked about DevOps. I talked about a lot of things, and you probably lost a lot of you. Hopefully not, but I talked about DevOps. I talked about open source, but I talked about how DevOps allows that automation of the process, but how cool technologies provide the hooks for that automation. One of those things is the new hottest cool thing out there is this whole Linux containers work, including the Docker initiative. And Docker spawned off this concept of using Kubernetes to package it up. And Kubernetes is going to scale someday, allegedly. All right, you would think with Google behind it, it would, but maybe you're right. But right now, Mesos is sort of the hot thing for getting scale across different types of workloads, and people are out there building frameworks today to sit on that. And you can write your own framework for Mesos if you wish. So, questions? Anybody? Are you all shy, like I used to be when I sat where you are? Yep.
So the scalability, right, of containers,
right,
is the key to that you're having a pared down set of libraries that your container is dependent on, because you're still bound by the resources underneath the kernel, right?
Right.
Whereas if you look at VM, you have hypervisor and then you have resources underneath that. So I'm trying to understand the order of magnitude of scalability of containers versus VM, hypervisor.
Right. Well, I mean, if you like, with containers, and I know we say the same thing about KVM, that we say that Linux is, with KVM, Linux is the hypervisor or whatever, right? But with a container, it's literally just a process. It's a process that has these extra libraries running in it. And it's the only resources available to it are what the kernel has provided underneath. And of course, as well as that, remember, when you're doing, you have to worry also, and this is the realm of Dave here, is when you get into this world and you're bringing up, let's say we're all bringing up web servers on the same host. Well, we're all bringing it up over port 80, right? So there's all this issue of, well, who's getting the real port 80 and how do we all do all the port mapping? And if I'm coming up on that port and it thinks it's port 80, but my rest of my application are on different machines and need to talk to it, how do I map on a some sort of private network or software-defined network, how do I map that application into the same namespace, kind of, but even though it's across multiple machines, right? And so the application thinks it's all kind of running together in the same namespace on the same machine, but really it's virtually sort of networked inside of your cluster of machines and talking to each other. And so there's isolation on the cluster part, right, where I'm saying, I'm here running on my own, you know, and I don't care about the rest of you in my application. But also there's isolation on the machine where my process that's part of that application is running on its own, and it's not messing with anybody else in terms of resources, but no one else is messing with it in terms of resources either, right? So if somebody turns around and brings up something that's going to hog the CPU, in Linux container world, the kernel will turn around and go, nope, you can't do it because you're only allowed to have this much CPU. So if you write a bad program, it's not going to affect me in the container world because the Linux kernel will make sure that you're not going to be crossing over those boundaries, right? Now, so I will take more questions, but in the second half, I'm going to attempt to show a kind of fun little demo, and then I'll also point, and I'll send it to you, Klaus, to a gist file on the web that you can go through some of these examples yourself with Docker and play with them, and you know, see how to turn around and do some cool stuff that I'll talk about in a moment. But questions first, yeah?
Is there any elasticity for the container in that situation where a program demands resources for compute power, say, or memory?
Generally, I mean, you can manipulate the C group stuff if you wanted to, but the idea would be that you wouldn't. That the elasticity would come from, like within the Kubernetes environment, you would define replicas and say, I want to replicate this particular container and scale it horizontally, and it would just bring up more containers for you, and then it would shrink them down if it didn't need it. So the elasticity would come from scaling horizontally and not trying to scale vertically. Does that make sense? Right? Yep.
Would it be a business case for having your application running across different cloud types? So part of the application running on Google Cloud, part of it running on Amazon?
Well, you could do it. You could definitely do it. Whether you'd want to do it, I don't know. But certainly there would be people who would say they might back-end part of their application internally on their own private cloud, but some of the front end might be, I mean, well, some of it might be out in, you know, hosted on Amazon. I'm not sure. I don't know when anyone's doing it yet, but in the containerized world, you could certainly wire it, right? I mean, probably not across the Kubernetes, not across in the same namespace. There would kind of be two different things running. I don't think you could. I haven't tried that, to be honest with you. It might be something that's a project like ManageIQ might be able to help work on, but that's. Generally, what people are looking for is saying to themselves, I want to deploy this application. So something like ManageIQ, right, which is a project out there, will allow you to turn around and define your application, whether it's virtual, whether it's VM-based, or whether it's container-based, right? And it will say, if you could set it up to say, look, I have it running for VMware, and I have it running. I have images for RedHat Enterprise Virtualization, and I have images for AMIs for Amazon, and I have whatever I need for Google. Now, I'm not talking containers here yet, right? But what ManageIQ will allow you to do is say, okay, I want this to run now, and you can set up rules that would say, if it's this time of day, or if Amazon is cheaper, I'll run it there, or if Google's cheaper, I'll run it there, and it will bring up the application with all of its components, whether it's 3 or 4 VMs, and run it there. And it can do the same thing around, you know, that sort of decision making around containers now as well, because it's just starting to support containers I think in November here is coming up. Probably upstream it already does. But the idea of that, so what you would do then is say, I'm bringing this up in GCE today, but you know what? When I'm running in North America, I prefer to run Amazon or something. Do you know what I mean? And so you could move from one to the other. But I guess you could, but they'd want to be very stateless and very REST API based, I'm assuming. But I bet you could do the other one. I'm just not sure if it would be Kubernetes that would allow you to do that. Like, here's the SDN across
Yeah,
two public clouds. That's
the dynamic
there's a problem for you.
Yeah, failing over from one to the other would be an issue.
Yeah, crazy.
I know Netflix doesn't. They have, like, if Amazon goes down, the service stays up.
Yeah.
But
I don't know if that's like having pods from Kubernetes crossing over each other. That would be much more like what I talked about, where it would just say, oh, that's down, let's bring it over here. Do you know what I mean? That's the other thing, great thing about, by the way, about containers as well is containers, they're stateless generally, and for the most part, their stateless state is on disk all the time, right? So in your Linux thing, it's /varlib docker, there's a container directory there, and everything that's going on, if you do write a file or do anything like that, it's in there. So you can actually, if you have bind mounted in, if you're using a VM, for example, and you've multiple VMs and you've bind mounted in some NFS type of thing into those, and you're sharing it across each other, you can literally turn around and bring up the container on another machine without even doing the copy, because it's there on the directory, just a bit like KVM, I suppose. But any other questions? Yep.
What's, in terms of networking, how is the state of Docker on, like, say, between physical machines? Because I know about a year ago it wasn't as good. It was grand on inter-container communication.
Yeah, that's where things like Kubernetes, and I think, is it OpenShift calls it OpenShift vSwitch or what? Yeah, you want to take that?
So Docker, traditionally, the Docker daemon uses normal Linux bridge. But that has some limitations for things like VXLANs or like interconnectivity of multi-tenancy across multiple hosts. So there's some work we've been doing from using Open vSwitch. And so there's one specifically for OpenShift or platform as a service that uses, specifically we do some pre-creation of VXLANs and VLANs and IP addresses allocated to ports and whatnot to speed up the networking connection. But there's also, you can just use for Atomic, just use Open vSwitch as a bridge instead of, and that's something, it's a command line option you pass to Docker. Command line is you just say -b and you use the Open vSwitch bridge instead of the Linux bridge, and then you get all of what you get with Open vSwitch, all of the open flow and capabilities and VXLANs and all that kind of It's a Linux bridge per host, and then what happens is that the Docker daemon allocates an entire /24 subnet to that host.
Yeah.
And then you have to have something that does the routing between the hosts. Right? That's kind of your problem.
Yeah, so on the bridge thing, here is on my Linux machine, you can see Docker 0 here. That's a default bridge you get with Docker. And
/16, sorry.
Yeah, it's a /16. And then so every machine, every process inside of it thinks it's its own machine, and it thinks it's root on that machine, right? And the Docker 0 bridge is the bridge between it and the real network on your laptop. But you could bypass that, or as he said, you can switch it over to the Open vSwitch implementation. But you can also tell it, I want you to use the host machine's network if you want as well. So anytime you do a Docker run, you can specify a bunch of commands. I'll go over some of these now for those who want to stay. But there's that's the Docker 0 bridge that allows you to, and also with the Docker bridge, so your application can expose a port, like port 80 or whatever, like if it's Apache. But then within Docker, you can turn around and map that to a different port if you want outside. So it means that your configuration of the machine itself stays kind of standard inside of the container, but outside you can do all these cool mapping things. And that's where things like Open vSwitch then will say, oh, he thinks he's on 80, but I'm going to give him this other thing, and I'm going to expose it on this network to these other machines that are on that network as well, so that the containers can do that cross-host conversation. Or you could use a host one as well, but then you run out of standard ports pretty quick. More questions? This stuff, Docker, is hot, folks. If you get into it, it's pretty cool stuff. Yep.
Is it normal to put the services as well inside the Docker image, like Nginx and just anything like
Yes,
that?
but usually in their own, like an Nginx application would have its own Nginx in the container. Now, the thing about it is if you're using, if you there's the other cool thing. If I turn around and pull down an image that has Java in it already. Supposing I pull down a Fedora image that has Java installed. If there's another image that I'm also using that has the same Fedora and Java image layers, I don't copy them down again. Do you get me? So it will just go, oh, I already have that. I'll reuse it again. So that's where the layering comes in. So you get reuse of the layers as well across applications. So if I download, if I have two containers that are using Fedora, I have only one Fedora layer, if it's the same version. But let's assume it is, because let's assume our corporation is using, hey, everyone should be on Fedora 22 or on RHEL 7.1 or whatever it is. Then the same image layer is going to end up on all of the hosts, right? And it won't be downloaded each time. And every single application every container that's using that layer will just use that layer. And then if some other container says, oh, it needs Java on RHEL 7, so it pulls down that layer, but then there's another one on the same machine that's also using Java. It'll go, oh, I already have that layer, I'm good, I only need the war file there. Right, so that's where the layers comes in as well. It becomes very, very economical in terms of space and so all of those things are running shared but not shared, right? Because they're,
Is that dynamic from every layer? So it's not.
Every time it's a layer, and every statement, unfortunately for some people, every time you put a statement in a Docker file, we'll see, and I'll go over those in a moment, it creates a new layer, even a temporary layer. But that layer gets copied with it all the way along. So that's why you have to be very careful if you're injecting any secrets into your layers, right? You think you clean them up afterwards, but they're sitting around in a temporary one. That's one of the things we have to worry about with subscriptions, and government agencies have to worry about with certain keys and passwords and stuff. You have to make sure that you're managing those smartly.
My question is about how do you secure that? If you've got that duplicated or available across multiple containers, is it the top layer which is going to give you the security there to isolate? They're
all read-only for all of the apps. Right, so each layer that I build into an image is read-only. Nobody can touch it, right? It's only the topmost layer that can be written to. Okay, does that make sense? But if you've left a secret, but that's why you shouldn't have deployed it in the first place, right? So there is a secrets directory, I think, on Docker builds. So one of the things we wanted to be able to do at one point, we said was, can't we just mount in a secrets directory during build and then unbind mount it later, right? But it turns out no, because of portability and all that sort of stuff. They said, no, you can't. What's in a container is in a container. There's no bind mounting during builds, right? But if you have the secrets directory, you can inject, like for us, subscriptions in there that allow you to download your Red Hat Enterprise Linux RPMs for building your image, but then they don't go with that layer when you're done. Does that make sense?
So, if, for instance, you've got some passwords which you've typed in, they're somewhere in
If they're in the layer, they're in the layer.
So
shouldn't be in the layer.
Invaded?
Invaded. Well, I mean, it's in the layer. And remember, when you're in a container, you think you're root. That's the other beauty of containers. They think they're root. They can do what they like in there, right? So if you're root in a container and something's in that layer, yeah, you can see it. So that's why you have to be very careful about that entire DevOps CI/CD workflow, that you're making sure that you're not doing anything nasty and getting stuff in. That's why it's so important that these layers are getting certified along the way, so you know what you're running, right? Because if everyone's just running containers willy-nilly on your net, you could be pulling in, God knows what you could be pulling in, malicious code in certain layers. So, a lot of people think this stuff, oh, this is great, it's free, it's portable anywhere else. You'll find that corporations are going to go, this stuff is great, people are running it all over the place, right? But they're making sure that they're auditing every single layer of what's going on, and they know where it's coming from and certifying it and all that. If you're going out to Docker Hub and you're just pulling down stuff, you don't know what's in there, you better be very careful. That's not good. So that's why Docker are doing a lot of effort around their certification, and you'll see things like official images from places and that sort of thing. And we're doing the same thing with our registries. Yes, Klaus?
I just wanted to suggest to have a small break now.
Yeah.
Thank William for...
Yay.